Hey everyone, and welcome to this explainer. Today, we are bringing some serious energy because we're preparing to hunt down, measure, and completely neutralize AI risks. We're going to be using the absolute ultimate guide for this, the ISO/IEC 42001-2023 framework. So if you've ever wondered how the pros actually make sure artificial intelligence doesn't completely go off the rails, well, you are definitely in the right place.
Okay, let's dive right into this. I want you to think about the genuinely terrifying potential of AI failures. We are talking about autonomous car crashes or healthcare diagnostics that misread a patient's critical scans. When these systems fail, the fallout isn't just a minor glitch, it can be massive. It impacts human lives and fundamentally shakes our trust in technology altogether. So, the big question is, how do we prevent these catastrophes before they even happen?
To answer that, we are going to act as risk detectives today. We'll start with the AI risk landscape, then hunt risks across the lifecycle and score them using risk matrices. After that, we'll prioritize the greatest threats, look at how to mitigate them, and finally wrap up with continuous vigilance. It's basically a highly structured, methodical journey from the chaos of the unknown to absolute clarity and control.
All right, kicking things off with Section 1, the AI risk landscape. This is all about embracing risk-based thinking. You see, this framework is entirely about shifting our mindset. We want to move away from reactive panic, scrambling only after a system has already failed, and move toward proactive management. The standard formally defines risk as the effect of uncertainty on the achievement of objectives. And in the incredibly complex world of AI, that uncertainty isn't just about simple software bugs. It includes massive social and technical unknowns that directly threaten our organizational goals, or even worse, societal safety.
These threats really have a dual nature. You've got technical risks versus ethical risks. On one side, an AI might be vulnerable to cyber attacks, model drift, or adversarial inputs. But on the flip side, an AI could be technically flawless, like completely locked down against hackers, but still be an absolute disaster if it lacks transparency or demonstrates algorithmic bias in something like a hiring tool. Both of these are absolutely critical risks under the standard, and both must be managed.
Moving right along to Section 2, hunting risks across the life cycle, from birth to retirement.
So threats don't just magically appear at the very end of development. They evolve over the AI's entire existence. If we walk through the chronological journey of a single AI system, we're going to spot specific vulnerabilities at every single stage. In Phase 1, design, we face algorithmic design risks like a lack of explainability. In Phase 2, training, data collection risks are massive. Just imagine incomplete datasets embedding biases directly into the model from day one. Phase 3, deployment, brings integration errors when the AI actually meets real-world infrastructure. And finally, Phase 4, post-deployment, is where model drift sneaks in, or where adversarial attacks actively try to deceive the system.
That brings us to Section 3, scoring with risk matrices. This is how we bring order to all that chaos.
Now, what's really interesting about this is how we actually manage all those abstract, frankly terrifying threats spanning the life cycle. You use the auditor's absolute ultimate weapon, a standard risk matrix. We objectively score a threat by plotting its likelihood of happening against its impact or severity. It's like a giant puzzle. For example, a medical misdiagnosis algorithm might have a super low likelihood of failing because of rigorous testing, but the impact of a medical failure, exceptionally high. That specific combination immediately escalates it to a high or critical risk, making it an urgent, top-tier priority for the organization.
Which leads us perfectly into Section 4, prioritizing the greatest threats, basically figuring out what needs fixing first.
Let's be real about business resources for a second. No organization on Earth has the time, the money, or the personnel to fix every single potential risk all at once. It's just not possible. By looking at a hypothetical threat distribution, auditors use these scores to separate minor technical glitches, say a low-threat UI rendering error, from absolute critical emergencies, like an autonomous vehicle's braking system completely failing. By visually breaking down the risk landscape like this, leadership knows exactly where to direct their engineers and their budget, straight to that 15% critical threat slice.
On to Section 5, treating and mitigating risks. This is where we shift to actually neutralizing the threat.
Now that we've prioritized the risks, the standard gives us 4 distinct treatment options to basically tame these AI monsters. Step 1 is mitigation, which means actively fixing the issue, like adjusting an algorithm's parameters to improve its accuracy. Step 2 is acceptance. Sometimes the risk is so minimal and the cost of fixing it so incredibly high we just accept it and move on. Step 3 is transfer, which often involves buying insurance against cyber attacks, or maybe outsourcing the risk entirely. And step 4 is avoidance, where the risk is just so severe we simply change the business process or shut down the AI application completely. No questions asked.
And this brilliantly illustrates what step 1, mitigation, actually looks like out in the real world. Here are some super concrete techniques. You can implement algorithmic fairness audits to ensure you're staying compliant. You can strictly mandate the use of diverse and balanced training datasets. You can add explainable AI or XAI layers. This one is absolutely crucial for demystifying black box algorithms, like judicial support systems, so humans can actually understand the AI's reasoning. And of course, for sure, you must enforce robust cybersecurity encryption to lock out the bad actors.
Finally, we reach Section 6, continuous AI vigilance. Because honestly, the job is never truly done.
Deploying a fix isn't the end of the story. AI systems are constantly learning, adapting, and sometimes they drift way off their original programming. A one-time fix is never, ever going to satisfy the ISO/IEC 42001-2023 standard. For high-stakes decisions, the standard is huge on having a human in the loop. The philosophy is simple. AI should augment human judgment, never blindly replace it. There absolutely must always be a human safety net ready, complete with escalation procedures, for whenever the AI faces uncertainty or makes a recommendation that directly impacts human lives.
To keep that vigilance up, the standard requires non-stop, continuous monitoring activities. We're talking real-time performance monitoring, conducting post-deployment compliance audits to make sure the system is still playing by the rules, establishing highly active feedback loops from stakeholders and end users, and doing regular retraining of the model on fresh, diverse data. Think of these as the daily habits required to spot model drift or brand new hacking tactics way before they turn into those catastrophic failures we talked about right at the beginning.
So, the crucial point is this overarching philosophy, which really ties everything we've covered together. AI risk is not static. It evolves with technology, user interaction, and contextual shifts. That right there beautifully captures the essence of the entire standard. AI governance has to be a living, breathing process, constantly adapting to the environment it operates in.
And that brings us to the end of our explainer. But before we go, I want to leave you with one final, slightly provocative question. Really think about the AI tools your organization uses right now. Is your AI system truly safe, or are you just lucky? I challenge you to go back and look at your own systems through the vigilant, highly structured eyes of a lead auditor. Thank you so much for joining me today, and keep questioning the algorithms.